Today we're going to look at 7.5, which is parts of similar triangles. So in lesson 7.2, we learned that corresponding side lengths of similar polygons are proportional. So we did a lot of triangle examples, and this concept can be extended to other segments in those triangles. So if you have special segments, so if you recall, if you look at these two triangles, when you have a segment that goes from vertex and it's perpendicular to the opposite side, if you think back to chapter 5, I believe, that would be called an altitude. So this is saying if you know that two triangles are similar, then altitudes are going to be proportional to corresponding sides. So that means if you look at this proportion, AD over FJ, the two altitudes would be equal to, and then you can just pick a side, AB over FG. I could also pick like AC over FH. Again, there's different ways that you could write this. I could also do like AD over AB, just pick two from the same triangle, and then I would put the other altitude on top, FJ over FG. So again, all of this, remember with proportions, is interchangeable and it could be written differently. Next picture, if you're looking, we have two angles that are congruent. So remember when you cut an angle in half, that's called an angle bisector. So again, if triangles are similar, then angle bisectors are also going to be proportional to corresponding sides. So you can see here LP over RT, so the two angle bisectors would be equal to two corresponding sides. So they picked LM, which goes with RS. Again, I could have picked KL and RQ. And then lastly, when you have a segment that goes from a vertex to cutting the other side in half or to the midpoint, that, remember, is a median of a triangle. And a median is also proportional to the corresponding side. So there again, you can see the proportion that's being set up. The medians, CD over YZ, would be equal to, this time, they're just showing you different ways you can write your proportion. They picked these sides. AB would go with WX. Again, you could have picked AC, which would go with WY, or you could have picked BC, which would go with XY. So there's different ways to write it. It's just important you understand those special segments are proportional. So example 1. In this figure, they tell us triangle ABC is similar to triangle FDG, so we're supposed to find the value of X. So notice I have angle bisectors, so I can take those angle bisectors and write a proportion. So I can do X over 8. And then I would set that equal to the side that I know from that other triangle is 15. And then 15 was AB, so I just want to check that AB matches FD, and I know FD, which is 12. And then I can cross multiply. X times 12 is 12x. 8 times 15 is 120. And then divide by 12, X would be 10 on that example. Okay, 1A. This time we're looking at altitudes, and we can do a proportion with altitudes. So I'm going to do 16, that first altitude, over the other altitude is X equals, and then the other side they gave me was 20. And I just want to make sure 20 would match up with that 15 because they have the same, just that one arc for the angle. So we know that those two sides are corresponding. Also, just as a quick reminder, we do know that these two triangles are similar because of angle-angle similarity. So you can set up a proportion for this because we do know the triangles are similar. And then we're going to cross multiply. 16 times 15 is 240. And X times 20 is 20X. And then if we divide by 20, X would be 12. Okay, and then on this one, again, on 1B, they're showing you two angles are congruent. So again, these triangles are congruent by angle-angle similarity. So because of that, we can set up a proportion with the sides. And this is median, a median one. So we're going to take 13.5 and put it over 9. Then that would be equal to X and over 3. And again, since those are congruent, It wouldn't matter. They're all going to match up. Then we're going to cross multiply. 13.5 times 3 is 40.5. 9 times x is 9x. Divide by 9, and x is 4.5. And there will be my answer. So make sure on these that you know the triangles are similar before you start setting up proportions. Okay, now we're going to look at some word problems where you would have to set up the picture. The first one I have done for you so you can see what this would look like. So it says, Liliana holds her arm straight out in front of her with her elbows straight and her thumb pointing up. Closing one eye, she aligns one edge of her thumb with a car she is sighting. Next, she switches eyes without moving her head or her arm. The car appears to jump 4 car widths. If Liliana's arm is about 10 times longer than the distance between her eyes, and the car is about 5.5 feet wide, estimate the distance from Liliana's thumb to the car. Okay, so here we have this picture. So we have, here are her eyes, right here. Here's the distance from her eyes to her thumb, okay? Here's the distance then from her thumb to the cars. And then this is where she was looking at the car, and then it looked like it jumped 1, 2, 3, 4 car widths. So to find what that distance is, we need to take 5.5 times 1, 2, 3, 4 cars. And that is going to be a length of 22 feet. Okay? So we know this is 22. We know this is x. That's what we're trying to figure out. How far is her thumb to the cars? This is 10 times longer than her eyes. So if they're saying that this is 10, then we can let the distance between her eyes be 1. Okay? And again, you could just make that number up. If it's 10 times longer, let it be 10, and then the other one can always be 1. And then the assumption is that it's going to be perpendicular. Her thumb, her arm out, straight out with her thumb, that's going to be a perpendicular line. So we can assume that those are altitudes. So we're going to take those altitudes. I'm going to do 10 over x, and then we're going to set it equal to 1 over that other side, 22. And then we're going to cross multiply. So we get 220 equals x. So estimate the distance from Liliana's thumb to the car, about 220 feet. Now we're going to do another one, and this one you'll be able to do the picture because you've seen it now. So suppose Liliana stands at the back of her classroom and sights a clock on the wall at the front of the room. If the clock is 30 centimeters wide and appears to move 3 clock widths when she switches eyes, estimate the distance from Liliana's thumb to the clock. Okay, so again, we have, here are her eyes, right? Those are really far apart, clearly. Whoa, and here's her thumb. Okay, so they already told us that that length is 10, so we're going to let this length be 1. Okay, so now we're going to talk about clocks on this one. This is the distance we're trying to figure out. What's the distance from her thumb to the clocks? So we have a clock, right? Whoa, you get it. And we're saying that the clock distance is 30 centimeters. And then they're saying, well, it jumped 3 clocks. 2, 3. So 30 plus 30 plus 30, that would be a distance of 90 centimeters. So now we're going to set up our proportion. So our altitudes, 10 over x is equal to 1 over 30. Oh, not 30, 90. Cross multiply, so 900 equals x. And so the distance from Liliana's thumb to the clock, we can either say, because this was representing centimeters, 900 centimeters, or if you want to simplify that, put it in meters. And to put it in meters, remember you would divide by 100, and that would be 9 meters. Okay? And then the last concept is that there's also something else you can do with an angle bisector. So instead of just taking the angle bisectors and putting them in your proportion, you can, so if you look at this picture, you can see the colors here. An angle bisector divides the parts of that triangle proportionally. So, for example, you can take this segment and this segment as a ratio and set it equal to this over this. Okay, so that's another option when you're given angle bisectors. So especially when, and this is true when you only have one triangle. So notice on the ones we did at the beginning on this page, we're talking about when you have two triangles for this angle bisector one. You have two triangles, and that's how you can set up a proportion. But now what we're saying is you can actually set up a proportion in one triangle if you have an angle bisector. So the triangle angle bisector theorem is taking the part. So here's my angle bisector. So my parts, it's splitting it. These two segments and then these two segments. So the key for this one is I have to know what this measure is, which I don't right now. But what I do know is that that entire length is 18. So if I want to know just that part, I can take the whole segment, which is 18, and subtract off that little part, which would be 18 minus x. And that should make sense because that's like your segment addition postulate. So then I can do these two parts. So the two segments that have a vertex at S would be 18 minus x over 14. That would be equal to, and then I can do these two segments that have a vertex at Q. And that would be x over 6. And then I'm going to cross multiply. I'm going to distribute that 6 in there. So 108 minus 6x is equal to 14x. Then I'm going to add 6x to both sides. So I would have 108 equals 20x. And I'm going to divide by 20. So x is 5 2/5 or 5.4 or 27 over 5. Okay, and then our last two examples. So notice again, we're looking at one triangle, but we have an angle bisector. So we can take these two segments as a ratio, set it equal to these two segments. So I'm going to do 4 over x equal to 6 over 13. And notice if I put 4 on top, I need to put 6 on top. Those go together. Those would be corresponding. And then we're going to cross multiply. So 4 times 13 is 52. X times 6 is 6x. And then we're going to divide by 6. So x is equal to 8 2/3 or 26 over 3. And then the last example, again, I have an angle bisector, but I have to do the parts of the segment. So again, I have to write this as the whole, which is 20, minus that other part, which is x. So now I can do 20 minus x over 11 equals, and then 20 minus x has to go with this other part here, x over, and then 14. And then I'm going to cross multiply. So I'm going to distribute that 14 in. So I would get 280 minus 14x equals 11 times x is 11x. Then we're going to add 14x to both sides. So that's 280 equals 25x. And then I'm going to divide by 25. So x is 11 1/5 or 11.2 or 56 over 5. Any of those answers would be sufficient. Also, as a reminder, you can check your 7.3 and 7.4 homework on Canvas. I posted the solutions, and I posted not just answers, but also the solutions so that it would explain it if you were a little bit confused about something. But message me on Canvas if you need some help. And here is your homework assignment. You're doing 6 through 16 all, 17, and then 20 through 24.